Hmm. Yeah, now it's on this screen as well, so that's good.
No, I'm not. Okay, YouTube is.
My internet is very slow, so I'm not able to see the streaming is started or not.
It looks like it's already recorded video, I think.
That is why we have to put this on pause mode so that we can. Otherwise, it will keep coming back to us as an echo.
I think there is a lag, I think.
That is what the 20-second wag. So that's why with the YouTube video, we have to put it on pause.
Yes. Able to see the stream, sir, because my very poor. I'm able to see.
Yeah, so I've put it on pause. So now we can see. What happened? Okay, so I think we can see how many people have joined so far on Zoom. Can we see the number of participants?
So we are live now. I will mute myself.
Okay.
We can start the session.
Yeah. How many people have joined, Murli? Do you know?
Right now, 4 are watching, sir, including me, sir.
So 4 and including you. That means 3 of us and one person outside. Does that mean? Does that mean? No.
Only one is. Yeah, I think so. So only one is there.
So there was some message.
As we progress. Yeah, as the session progress, few might join, sir.
Yeah, I think
in case if students are asking any questions, then we will wind up the session, sir.
Of course, we'll do that. That's not a problem. That's not an issue.
Okay, sir. I will mute myself, sir.
Yeah. So what we'll do is we'll say hello to all these people who have joined. I think only one person has joined, or maybe. And that's what I can guess. I can see only Mr. Clinton Pereira who has joined. Good evening, Clinton. How are you? Well, Clinton, you have said that I've posted my queries in the Google form. So that form, what I have in the form, I can see that.
Can you hear actually from Clinton Pereira?
No, he has to write something on he'll have to write it on in the chat box, I think.
Good evening, sir. So he's here. Yeah, good evening. Yeah.
So you can see the chat coming in the live chats, right?
Okay. Yeah. Yeah.
Good evening. That's good. So I think that's where we are. So we can see the interaction with Mr. Pereira, at least. If there are others, we'll have them join sooner or soon. So we don't see anything written by you, Clinton, on the Google form. There are only two questions.
No, there are, I think, 4 questions that are written.
So not from him. So there is one from Santosh Padmanabhan. There is something from Prasad Bisetti. And the next one is also, there is something up from him after that?
Yes, yes. I'm able to see Clinton Pereira's question.
Okay, fine. So if you're able to see that, then maybe we can start talking about it.
Okay, let me just read it quickly. Assignment statement 1: gypsum content does not affect the lime saturation factor. Gypsum is added at grinding stage in the ball mills and not at clinkering stage. Hence, in context of burnability of clinker, the statement gypsum content does not affect lime saturation factor is true. Kindly provide your views as how this statement is false. To calculate LSF of clinker, we do not consider SO3. However, for calculating lime saturation factor of cement, we detect a 0.7 into SO3. So that is what is the first question. So Clinton, the way I understand is that in the question we have not mentioned whether it is clinker or it is cement. So lime saturation factor by if you read the slide or if you hear our explanation, you will find that it's a calculated value. It has certain oxides that is taken into consideration in the calculation of lime saturation factor. So the question asked is not precisely for clinker or cement. The question asked is whether the gypsum content affects the lime saturation factor in the calculation. So that is what is important. It doesn't matter whether it is clinker or it is cement. So if you see the chemical constituent of gypsum, it's typically CaSO4.2H2O. So you have a water, you have a water part, you have a sulfate part, you have a calcium part, right? And if you see the lime saturation factor formula, you will not have, certain oxides, but you will have calcium oxide. Okay, so the only thing that we want the students to realize is in the calculation of lime saturation factor, do you consider any of these oxides, which are or compounds that are present in gypsum? So obviously, the calcium oxide is a constituent, and gypsum has calcium content in it, and sulfate also, right? So that is what we want the students to sort of realize. And so the answer is obviously, the answer that you have provided is actually wrong. So we don't have to really consider the grinding part, or clinker, it is like this, cement, it is like this. You don't have to get confused. Okay, so that is what I would sort of explain the answer to be. Professor Misra, you want to quickly comment?
No, that's fine. I think that's
I think
fine.
it's very open. I think the question is very clear. I don't think so there is very difficult to understand or something. So if you have any comment, you can quickly write it in the the YouTube or something. So Clinton Pereira has written that I'm fine. Hope you are fine. Yes, I can hear both of you. Considering
that was before the chat, so I think
was before
yeah.
the chat.
So
Okay.
I think now we can go. You go to the second question, which he has with reference to question 3, statement 2, that reactivity business.
Okay.
So I think this is the question that I had flagged to you and sent it to you, because this is, I think, coming straight from the comments which he had given in the Google form in the forum also.
Okay.
Okay. Yeah.
Just a minute. So the next one is with reference to Q3 statement 2, the increasing order of reactivity is C2S lower than C3S, lower than C4AF, lower than C3A. The slide in lecture 13 on cement hydration mentions that when water is added to cement, C3A reacts first. That's correct. Then C3S reacts to form a coating around the cement grain. That is correct. After 18 hours, C4AF starts hydrating. That is also correct. So the order of reactivity should be C2S lower than C4AF, lower than C3S, lower than C3A. So kindly provide your view. So I think the point you are trying to raise is that you have a question whether which is more reactive, C3S or C4AF. What you need to know is you might have to look into some of these slides related to heat of hydration. Maybe there is a table that is provided in under heat of hydration, which can actually say how much amount of heat is developed by each compound. So again, I remember that there has to be something like for pure compounds, there are some heat of hydration values. For the halide, belite, the impurities embedded in that, there will be separate, heat of hydration values. If it's going to be cement, there has to be some values. So you can quickly have a look at it. And it's actually, there are two things. One is both are reactive, but because you have iron content in C4AF, it is relatively less reactive than C3A. That is for sure. Now, between C3S and C4AF, you need to understand that the quantity also matters. So if you take C3S, it's present in huge, quantity. So that is one reason why, C3S reacts a little more faster. So the quantity to some extent also matters. But the table there will provide a much clear picture, heat of hydration table. And I have also seen that question carefully. I think C4AF has a higher value. C4AF has, I think, lower value than C3S. So there could be some error from our side, which we will sort of rectify. We require some time to do that. So that is what I would say about the second question. So maybe we will check the table values and get back.
So he has written the something on the chat box just now. Consider the following. What it says is, consider the following statements in the context of burnability of clinker. That is the statement for the first question.
For the first one, see, because I said to him in this meeting that you don't have to focus on clinker or cement. See, the point is the burnability calculation comes only with respect to clinker. That is the way you will find it in several textbooks or fundamental textbooks. But in the question, what we are asking is whether gypsum has anything to do with the calculation of the lime saturation factor. So the thing is, I still don't know why it has to go to the grinding part. It's not very clear why you should go before grinding, after grinding.
His question is that since gypsum is not a part of the clinker, the question of gypsum being involved in the burnability of clinker does not arise. That is, I think, the way he's looking at it.
No, but why should he look gypsum as a part of Portland cement? You can always you can add gypsum later also, not in the manufacture of Portland cement. So, hello.
Yeah, I can hear you, of course, but
see, if you take the burnability question, burnability slides.
Mm-hmm.
So there is a burnability of clinker and you have a formula that is given. And in the next page, it is mentioned that if you have sulfides, SO3, sulfur dioxide, then that part of it has to be removed from, the lime saturation factor formula. So, but the point is, it's about whether or not you use, if you have gypsum in the mixture, whether or not you will use it. That is what it is. So, so I don't know why he has to get confused between, before grinding and after grinding. I know it looks a little different actually.
Well, Clinton, I hope the questions are answered to you. And for the second question, I think the question is...
No, second question, I think it could be fair enough that C3S could be, a little more reactive. We need to find out from that heat of hydration, table.
See, what I wanted to add was that there are two issues involved here, and that's what Professor Harish is saying, that we'll take a look at it and see what exactly the numbers that we have given you. One is the order in which the compounds react. So one compound reacts, and then after some time, the second compound reacts, and the third compound reacts. That's one part of the discussion. The second part of it is the amount of heat liberated when the hydration of each of these compounds happens. So now the word reactivity, the way it is written here, the increasing order of reactivity and the reactivity and so on and so forth. One way of defining it would be that, okay, a compound that reacts first is more reactive, regardless of the amount of heat of hydration generated, because the heat of hydration generation continues over a long period of time. So some compound, I'm not commenting on this particular C3A or C4AF or C3S, but my point that he's getting confused probably is that if C4AF reacts later, then regardless of the heat of hydration, the C3S, which reacts first earlier than C4AF, for example, that should be called more reactive. The other way of looking at it by definition is that we will define reactivity in terms of the total heat of hydration liberated for that particular compound. So that is when the table comes into picture. The first part, as to what is the order of reaction, or which of these fellows starts to react first, that is a different discussion. So I think if Professor Harish, you could comment on this from that point of view, that will probably answer the question to him better.
See, that is what there is one table in which we have given, the reactivity to be, I think, moderate for C3S and moderate for C4AF. So it doesn't really say which is higher or which is lower. So, but I think if one has to follow our lecture, I think what Pereira says is correct only. I think there is some error in from our side that it should actually be C3S, which should come next to C3A. So I think that is what sort of confuses, I think.
Fine. So that is something which we'll look at, and if for the assignment, we'll correct it as far as the assignment and its grading is concerned.
Yes. So yeah, that we need to look at. Yeah.
Yeah. And as far as now coming to the third question which he has raised, that says in the context of using high water reducing agents, WRAs in concrete, identify the false statements from the false. Is statement 2 also false, which says WRAs can be used to reduce the cement content in a concrete mix, thereby help in developing higher strength concrete or something like that, in development of high strength concrete. As the water reducing cement content, high strength concrete cannot be produced. Well, what is the statement? WRAs can be used to reduce the cement content in a concrete mix. This statement is, if I don't remember, if I don't completely remove myself from any of the discussion that I have done or Professor Harish has done, if I look at this question, WRAs can be used to reduce the cement content in a concrete mix, thereby help in development of high strength concrete. To me, this statement is true, because by reducing the water reducing agents, there is a way of reducing the cement content. Okay. You are, in fact, there was, if at least in one of my lectures, I suppose there is a table somewhere which says that, okay, how you can use the water reducing admixtures. The water reducing admixtures can be used either to reduce the water content, and when at a reduced water content, if you maintain your water cement ratio, you will reduce your cement content. If you do not reduce your water content, you will actually have reduce the water cement ratio, and therefore you would have contributed to higher strength. So in that context, this statement should be interpreted and seen.
Yeah, I think it is true only. I think it is true. So I think what he has raised is right. Maybe we need to again look into the question.
So we look at that question and redefine the answer if it is required. That's not an issue at all. I mean, Pereira, I think does that answer your question? I hope it answers your query. Yeah. So I think what he's written on his chat is that, yes, sir, my focus not on the marks. I want to understand the concepts from experts like you. Well, thank you so much for that. for the kind words. And the concept is simple, is as simple as that. Okay. And then if you go to the next question, which you have raised, question number 6, identify the true statement from among the following in regard to AAR of concrete. Why is option incorrect? AAR is caused due to the presence of alkali and reactive aggregates. Okay. AR is caused in the presence of, what does it say? AR is caused in the presence of alkalis and cement, reactive aggregate and reactive silica and aggregate, moisture and temperature. So
No, I think there also, I think there is some error or something.
no, there is no error. See, it's like this. See, if you are able to get rid of moisture altogether, then you will probably be able to reduce the damage or deleterious action of AR. Temperature is indeed one of the players in the whole game. So what you're saying is correct. AR is caused by in the presence of reactive silica in aggregates and alkali in the cement. And moisture, most of the time in concrete, we can assume that it is present, or at least it will remain, there will be sufficient moisture so as to cause some deleterious reactions. So in principle, this statement is AR is caused due to presence of alkali and reactive aggregates. Because only thing that's not mentioned is the alkali is coming from the cement. On the face of it, the statement looks to be correct. So we'll probably take a look at the statement as far as the question is concerned in the assignment and make a correction if it is required. But I suppose we have clarified the basic picture.
Yes, it appears to be correct. Yeah.
So that's what we'll do. Moisture and this thing is not really a major player as such, at least in that was not the spirit of the question.
Right.
So then there is the next question, which I think, Harish, maybe you can take it up, which says which of the following.
Which one of the following shows the correct order of the compound composition
percentages in this
by weight percentages in Portland cement? So C2S greater than C4AF greater than C3A greater than C3S. C3A in all cements manufactured in India is in the range of 6 to 10%, and C4AF is in the range of 12 to 15%.
So as far as his, I mean, if this data is to be believed, then C4AF, there is more C4AF than than C3A in the cement. Is that correct, Pereira? Is that what you're saying?
No, chemical correct order of chemical composition by weight. So what is his question actually?
So maybe the order is given is something different. So I think
the order is wrong, right? Because C3S is present in higher quantities, correct? Followed by C2S, followed by but that order is wrong.
The C2S is the maximum. That is what is shown here.
No, that's wrong actually.
Yeah.
Because C3S is the highest, followed by C2S, followed by C4A, followed by C3A. So I don't know why he has to get confused with, moderate sulfate resistance. And Pereira, I think you got little confused with moderate sulfate resistance and other cements. So we are talking only about Portland cement. Of course, you have different types of Portland cement, but you don't have to get confused with, different types of Portland cement. Okay, so I think you need to concentrate on C3S. That we are talking about the general, general cement that is available. So what you are saying is, hence in my view, C4AF is higher than C3A in most cements manufactured in India. That's correct. No doubt about that. But I think the order...
Except that in both the cases, C3S cannot be the least.
C3S cannot be the least.
That is the crux of the matter.
Yeah,
as far as this order is concerned.
Yeah, C3S should come up front actually, and the remaining orders are fine.
Okay.
So I hope that answers your question. So
yeah, so that answers your questions, Pereira. So let's move to the other. My question is, which is high? My question is, which is high? Which is which
No,
is
that's
high
correct.
in
So-
OPC C3S or C4AF. So of course, as far as C3S, C3A and C4AF is concerned, C4AF is higher than C3A. Is that correct?
Yeah, C4AF should be normally higher than C3A.
Should normally be higher than
Higher
C3A.
than
So
C3A.
that
That's
part
correct.
is that there is no disagreement on that. So I think that's where the matter can be allowed to rest. So I think what he says, the order was this order was wrong. So I think that's fine. That's okay. So then we go back to some two questions.
So I think he's trying to say that this order was wrong in our.
If that is the case, then that we'll take a look and decide.
Yeah.
Yeah. So in all these comments, we'll take a look, and if they make changes in the assignments or solutions, whatever may be required.
Right.
Okay.
So maybe we'll have to go to the other questions.
Yeah, we'll have to go to the other questions. So one of them is by Santosh Padmanabhan D, which is who's coming from a student, which says, what are the main topics which we have to concentrate on the subject from the exam point of view? Well, all topics, because if I don't remember the questions, but is Santosh there today or not there today? Now that is the bigger question. That's the question that I have. Santosh, are you there? Does not look like it. Okay. Murli, are you there? Can you hear us? There is a question from Santosh and there's a question from Prasad Bishetty. So these people are probably not there in the discussion. So
No, that's okay. I think
that's
we can
okay. So we can leave it, and that's why the session there is a recording, and if they want to listen to it, of course.
No, what are the main topics? I mean, all are main topics. So
all are main topics, because if I don't remember the question paper, but basically the question paper is prepared that all the entire subject is more or less equally represented. I mean, it may not be to the last mark, but yes, no topic is really more important than the other. Okay. Then there is a question from Prasad Pishetty, who's a faculty member somewhere, which says that my question is, when we add water reducing agents, the cement particles, they get repelled due to formation of negative charges over the surface, and we get good workability. That's okay. And then what happens next? How are they removed from the surface, and how does the effect? How, if this affects the admixture reduces, how does the admixture reduce with time? Please explain. So, well, to my mind, I mean, I'll probably have Professor Harish also explain it later in a bit, but to my mind, this development of negative charges and the cement particles not being able to coalesce or form flocks, this is something which happens, and that is what releases the water which would have otherwise got trapped in the flocks for hydration and so on, or not for hydration, for workability. And so that is how the workability increases. Now, these negative charges, it's only a matter of time, and these particles, once they are separated, they remain separated, and therefore the particles do not come back together. So so over a period of time, the effect of negative charges probably wanes, and the hydration of the cement particle continues. So, I mean, one way of, well, maybe just understanding it would be that the cement particles are separated because of this negative charge. But if this charge was such that it does not allow the water to come in contact with the surface of the cement, then the hydration will be completely impeded. And if that happens, that there will be major problems. So that's a separate discussion. And over a period of time, the admixture effect whether it reduces or not is a moot question, because at the end of it, we are interested in workability only with a short-term perspective. So once the concrete has been placed, then we do not want the concrete to remain workable. I mean, unless we are looking at it from the point of view of retardation, where we want more time for the cement to hydrate, and I mean for the concrete to hydrate, and so on. So that not being the normal objective, once the concrete is placed, the cement hydration proceeds in a more or less regular manner. So, Professor Harish, would you like to add to this some comment on this question which he has? Yes. The cement particles getting a negative charge and so on?
Yes, yes. Firstly, if you follow the lecture, what we would have said is cement particles contain more calcium oxide. So that means they are more positively charged. And if you take the ions in maybe the super plasticizers or water reducers or water reducing admixtures, they typically have two ends. One end is negative, the other end is positive. So when you have a cement mixture which is largely positive because you have calcium ions in it, the ions in the one end of the ions in the water reducing admixture, primarily the negative, will try to get attached to the positive in the cement. Now that happens with all the cement grains, and hence the other end, which is actually positive, other end of the water reducing admixture is positive, so that is free. And likewise, if you see another cement grain adjacent to that, there also you have a negative end which is getting attached to the cement particles, and the positive end is actually free outside, and hence you have a positive and positive repulsion that actually comes between the super plasticizer, and hence, as already Professor Misra said, cement particles cannot get attached, and hence you get the the workability, more like a lubrication effect, because negative and negative particles tend to positive and positive particle tend to repel each other, so you get a lubrication effect. Now the second part of your question is what will happen with time. See, what you can recall is water reducing admixtures typically contains at least I would say 40 to 50% water. Okay, and only the remaining 40 to 50% could be the chemical actually. So what happens, it contains a lot of water. So when it actually does this the repulsive effect in the early stages, so that's fine. And in the early stages you will have through solution mode. That means water that is present on the surface of the cement grain will try to go into the grains for reaction. Now with the time after say final setting time, or maybe after a day, the entire hydration goes into a diffusion controller state. So now what happens to the admixture? And when I say what happens to the admixture, I'm precisely asking what happens to the the solid content. The solid content still is there in the surface, but it can't really do anything more than just sticking on to the surface and then getting dried off after a period of time. So that is why we generally try to say that the water reducing admixture is more active at the early stages, and at the later stages it either gets dried off or the water content is basically used by the cement in the hydration process, and hence there is literally no effect. And the charge effects are very, very minimal, especially at the latter ages. So I think that is what it actually means. So I hope that explanation is good enough. So anything, any other question? I'm not able to. But by chance is Prasad Bishati there in the YouTube? If you are, you can probably send a message if that explanation is sufficient or not. Hello, Professor Misra. Hello. Hello, Professor Misra. My voice is audible.
No. You are very much audible. I had muted myself for a minute. So
I'm just waiting if they are trying to, respond in chat. So I've already given that explanation. So. And there is also
Clinton has a last question.
Yeah.
Clinton has raised one question. There's just one last question. What happens to chemical admixtures in concrete with time? Do they become an integral part of the paste system? Cement paste system, that is the question that he has raised now. What happens to chemical admixtures in concrete with time? Do they become an integral part of the cement paste system?
Yeah, so the answer that I would give is it's not a very integral part of the cement paste system, because see, the water in the super plasticizer may be utilized in the hydration process. And since the hydration process starts from the surface and then goes into, into the inside part, already you will have, the calcium silicate hydrate gel, etringite, and other things which are already formed on the surface. So even if you have, in localized areas, if the content of water reducing admixture is so concentrated, still it's not going to be a integral part of the cement paste system. So it's going to be always the the water to cement ratio that's going to be more important. And that is one reason why even the water content in the water reducing admixture needs to be accounted in the mix design. So because that is also a significant quantity of water, especially when you have water reducing agents which are added in the range of 1 to 3% by weight of cement. So that is my explanation to that question.
Yes, so I think that's a fair answer to what has been shared by them. So I think we don't have anybody else who's there, and there are no comments. So maybe we can close the discussion.
I think only it looks like only one student has joined in the chat. I think maybe
Yeah,
they have
so-
they
yeah,
thought
so
that
I-
if it is put in the Google form, I think we will directly address the questions and live. So that we have done.
Yeah, so Clinton says, thanks a lot. Thank you, Clinton. Thank you for
Thank
joining.
you, Clinton. Yeah.
Clinton, I think I understand you are already teaching somewhere. So where are you teaching?
No, I think he has not responded.
He has
Clinton,
not
are you there?
responded. So Murli, are you there? Are you able to hear us? So we can, what I just wanted to check with Murli is that whether we can close the interaction now, because if we have a talk
Yes, sir,
to
we
the,
can close the session.
we can close the session. Okay,
Yes,
good.
sir.
Okay.
So, okay, Murli says, thank you so much. That's fine. Thank you. We will end the session. Thank you, Murli. Thank you, Clinton, for joining.
Yeah,
And
thank
we
you. Thank
will
you to
sign
one
off.
and all.
Thank you, one and all. Bye-bye.
Thank you.
Okay,
Bye
sir,
bye.
I will end the stream, sir.
Oh, Clinton says, no, sir, I work with Ultratech Cement. Okay, very nice. It's no, you don't work, you don't teach, you work with Ultratech. Okay, good. Nice to know that. So I think all these questions, oh, that's all why you have a deep interest in how cement works or how cement hydrates and so on. Good. I hope you find the material useful and good for you. Okay. So Murli, we can close the discussion. I'll sign off the meeting. I'll leave the meeting then.
Yes, sir.
Okay. Thank you, Murli.
Yeah.
Thank you so much. We'll
Okay,
talk
thank you,
offline
Murli.
then. Okay. Bye. Okay. Professor Harish, we'll talk
Yes, sir.
later then. Yep.
Yeah,
Okay,
sure,
bye.
sure. Thank
Yeah.
you. Thank you.
Okay,
Bye
bye.
bye.